Welcome back to my latest video on testing and DevOps. And in this video, we're going to talk about performance testing. So performance testing helps us understand how well our system holds up when it's under load. So whether that's normal traffic, extreme spikes, we want to know how our application is actually performing out in the wild. So we've talked about a lot of different testings, types and where we do that in our pipeline and kind of the whole methodology at this point. And we're coming down to the end. We've got this one and one more to go to talk about. But, really the goal here is to identify those bottlenecks. A lot of the testing that we've talked about so far is testing that happens before release or during that pipeline on its way to production. Performance testing happens post-production, right? We've deployed it, it's out there, users are using it. So are there slow response times? Are there scalability issues? We can ensure our app can handle real-world traffic. And it really helps us plan our infrastructure needs. So we're going to go over what performance testing is, why it's important, some different types, and also, how it fits into your DevOps workflow. So some tools. There are lots of great tools out there that help us simulate load and measure performance. Now, I said that performance testing normally happens after deployment, and that is where most people do it. But you can use some of these tools to simulate load so that you know that it's going to work at the expected rate limit without bottlenecks and issues before you actually put it out in the wild. So things like JMeter, this is a GUI tool that can test your APIs and your databases. K6 is a scriptable load testing tool written in JavaScript. Another popular one is Locus, which is a Python-based tool, great for testing your API behavior. So we have a lot of tools, like we've talked about before, so many tools. These tools help us model how users interact with the system and then stress it before real traffic does. But then, of course, we can use tools to test it once it's out in the wild and actually measure the performance and use our logs in order to determine, is it actually performing the way that we want it to? So really what it comes down to is, what is performance testing? Because a lot of times with performance testing, we're just thinking about load. But really it's about speed. So how quickly does the app respond? Scalability. How many users can it support? And if you have burstable infrastructure, maybe you're using AWS and you've got your cluster set up so that it will expand under load, you're testing that. How many users can it support in a spike? And then the stability. Does it hold up over time or does it degrade? So we might be able to handle 1,000 users all at once, but can we handle those 1,000 users for the next hour? So it really helps answer some of the questions that we might have. Can we handle those 1,000 users simultaneously? Is our checkout API still responsive under stress? The last thing you want is to have, deployed your application. It's great. You've done all the right things, but because you didn't performance test it, all of a sudden it goes viral, hits the front page of Reddit, a product hunt, something like that. And now you have thousands of users trying to check out, trying to use your application, and they can't. And so you're losing those customers and kind of creating a bad first impression. So there's a couple of different types of performance testing, and I know you might hate to hear this because we've talked about lots of different types of testing. So please don't be like, oh my God, are you telling me that there's subtypes of testing? Yeah, I am. So these are some of the main types when we talk about performance testing. So load, that's the one everyone thinks about. We are talking about expected traffic. How many users can we support at one time? Browsing, buying, using the system. Stress test is when we push the system until it breaks. So maybe we're stable at 100, maybe we're stable at 1,000. What happens if we hit 10,000 requests per second? Is our system designed to be able to handle that? Or what happens if we do. Spike testing is what happens when we get sudden bursts of traffic, that viral, post or Black Friday traffic. What happens when we normally have a reasonable amount of traffic that we've planned for, but suddenly we get those 10,000 requests all of a sudden. Soak testing is where we run for a long period of time to find those memory leaks, timeouts, slowdowns. So when someone talks about soak testing, it's almost the opposite of the burst testing or the spike testing, where we're looking for that sudden increase in traffic. And we're like, what happens when we just get all these users and then can they do what they need to do and then they leave? Soak testing is when we have processes that run for a really long time. Do we have those memory leaks, and is it going to start to slow down our application or even crash it? And then baseline testing establishes how our system performs normally. If you don't have a baseline, you don't know where normal is, and so this is how you know when things change and move out of that baseline. So it's important for several reasons that maybe you've caught on to, but we want to do performance testing because it ensures fast response times, which keeps our users happy. It provides a system that can scale as our user base grows. It helps us find those bottlenecks in our database, in our caching layer, in our code, all of those areas that could just be holding something up, which can then, honestly, from a developer standpoint, help us prioritize where our efforts should be post-deployment. It helps you prevent outages by catching issues before users do. And again, we don't want them to have a bad impression of us. And it supports predictable deployments. So we never want surprises on release day. We never want release day to be so super stressful because we kind of historically get those surprises. So by doing the right testing and following all through these different types of tests in our pipeline, we really do make it a much less stressful environment on release day. So I talked about some tools, but here, dig in a little bit more, some tools aligned with some different stacks, because at this point, hopefully you understand, the tooling that you use really does depend on the stack, the language, the server that you're working in. So we have things like Apache's JMeter that is great for Java environments and API testing. I talked about K6, JavaScript-based scripting, Locus for Python. Artillery is a great one for Node.js. It's a command line type testing suite. Gatling for Java and Scala pipelines. And then Visual Studio Load Test is popular for our .NET, but it's retired now. But if you are using any legacy systems in that .NET, not core, right, .NET framework, you may actually encounter the Visual Studio Load Test product at some point. So here's an example in K6. So this is JavaScript. And we can see here that we're simulating 50 users over 30 seconds. And going back to our previous video talking about, sometimes we need these endpoints to know whether or not our system is up. So we have a health endpoint that we can see that we're hitting in there, right? yourapi.com/health. So that health endpoint probably just gives us a 200 OK response. And we check for that and ensure it responds under 500 milliseconds would be, maybe a nice benchmark for us to decide. You could choose a different number if you wanted. But this is the kind of quick test that you can run in a CI environment to validate performance on every push, just to make sure you don't have any weird bottlenecks or recursive actions or something that might have gotten hung up and are causing, some kind of delay where it won't respond in that 500 milliseconds. And then where does performance testing fit in DevOps? So if we're doing the pre-flight performance testing, so that's the simulated users before deployment, right? We can put it in the CI pipeline and run our light load tests on important endpoints every time we push to the pipeline. So every time we build and get ready for moving that out to production. We can also do this in staging and run full load tests, our stress tests, our soak tests, and do all of that in our staging environment. And then in production, we use our monitoring tools to track our live performance and get alerts to see if anything degrades. And that's where having those benchmarks are important, those baselines, so we know when our real performance is getting out of band. So some key metrics to track. You might be thinking like, okay, like I'm down. Let's run some performance tests. But like, what am I actually measuring? Is it just about load? Is it just about response time? There are lots of different metrics that you can test in your applications to make sure everything is working well. So response time, of course, that's like the one everyone goes to. We want an average at, the 95th to 99 percentiles. You can go look at what those would be. 500 milliseconds was a great example of that. Throughput, which is your requests per second. We can look at error rate percentages of failed requests, which will start to show you maybe if your application is starting to have too many requests that it can handle in a timely manner, or things are starting to become dropped. CPU and memory usage, database query times, and then if there's a frequency of app restarts and crashes, that would give you a good idea if something isn't going well. So these metrics can really help you pinpoint problems and then validate your improvements. So some common pitfalls, right? Some mistakes to avoid that would be outside of our best practices. We want to test more than one endpoint. Be sure to test end-to-end workflows. Remember thinking about, is that critical path that the user would take through your application. That's what we want to test. If you only test one endpoint, you're probably not going to catch the full story. We don't want to ignore the back end. Always include your databases and your API in your tests. We don't want to use unrealistic scenarios. So model your actual usage patterns and data. And if you don't know what those are, start logging and monitoring so that you know where your baseline is. Skipping your soak testing is a pretty common problem. Long-running tests can really reveal issues that short tests miss. So finding those memory leaks, finding those gradual slowdowns. I know that soak testing is time-consuming, but running those on a regular basis can really help find problems that you're not seeing in other tests. And then performance monitoring, right? We don't want to stop at staging, right? With that, some people call that pre-flight testing. We want to monitor in production as well. So tools like Azure Application Insights, Datadog, New Relic, Prometheus, Grafana, CloudWatch. There's lots of different monitoring tools that we can use that will grab these metrics we've talked about and help you track your latency and your throughput, error rates, system resource usage, and you get all of it in real time. So you can set up alerts in these tools so that suddenly you get a ping if something is out of band, and that way you can catch those as they're occurring. So hopefully this has introduced you to some new ideas about performance testing that maybe you didn't already know. I think performance testing is kind of like on people's radar, but maybe you've not dug into it before or really thought about all of the metrics and best practices on how to set performance testing up for your application. So just in summary, right? Performance testing is how we make our software fast, reliable, and scalable before users can tell us that it's not, right? We don't want our users getting that bad impression of us, that bad taste in their mouth because our application doesn't work as expected. It protects that user experience. It gives your team confidence that what they've built will hold up under pressure. You can prove it. You don't have to guess. So hopefully, again, you've learned some things about performance testing. Thanks for sticking with me. We've got one more testing type to talk about in this section. So I hope you've enjoyed this video. Let me know in the comments if you have any questions, and I'll catch you in the next video. Thanks.